Tonight's bedtime lesson is about, unfortunately, it's not another sport. Sorry. It's about temperature. Whether on a thermometer or simply through something feeling hot or cold, temperature is one of the most fundamental parts of weather. It was discovered a long time ago that the physical properties of certain things, such as their size, varied with temperature. In terms of weather, temperature governs huge global scale circulations, such as El Nino, to small-scale occurrences like frost. Here we look at few temperature-related phenomena. Now there is going to be 3 parts to this lesson. The first part is about what is a heat wave. A heat wave is an extended period of hot weather relative to the expected conditions of that area at that time of year, which may be accompanied by high humidity. A UK heat wave A UK heat wave is met when a location records a period of at least 3 consecutive days with daily maximum temperatures meeting or exceeding the heat wave temperature there hold. The there hold varies by UK county. See the UK temperature there hold map below. You can see on the internet. Why do heat waves happen? Heat waves are most common in summer when high pressure develops across an area. High pressure systems are slow moving and persist over an area for a prolonged period of time, such as days or weeks. They can occur in the UK due to the location of the jet stream, which is usually to the north of the UK in the summer. This can allow high pressure to develop over the UK, resulting in persistent dry settled weather. Are they linked to climate change? Heat waves are extreme weather events, but research shows that climate change is making these events more likely. A scientific study by the Met Office into the summer 2018 heat wave in the UK showed that the likelihood of the UK experiencing a summer as hot or hotter than 2018 is a little over 1 in 10. It is 30 times more likely to occur now than before the Industrial Revolution because of the higher concentration of carbon dioxide, which is a greenhouse gas in the atmosphere. As greenhouse gas concentrations increase, heat waves of similar intensity are projected to become even more frequent, perhaps occurring as regularly as every other year by the 2050s. The Earth's surface temperature has risen by 1 degree since the pre-industrial period, 1850 to 1900, and UK temperatures have risen by a similar amount. Heat wave impacts. The UK experiences occasional heat waves, but of a lesser frequency and intensity of those seen elsewhere globally. A new record high temperature for the UK was of 40.3 degrees Celsius, was recorded in Coningsby in Lincolnshire on July 19, 2022, along with new records for Scotland on the 19th July and Wales on the 18th. The extreme temperatures were recorded as the UK was impacted by an unprecedented heat wave, with the previous UK temperature record of 38.7 degrees Celsius, provisionally met or extended at 46 stations, from Kent to North Yorkshire and from Suffolk to Warwickshire. To aid in the preparation awareness before the during a spell of a very hot weather, an adverse weather and health plan has been created by UK Health Security Agency in occasion with the Met Office and other partners. It recommends a series of steps to reduce the risk to health from prolonged exposure to severe heat. The NHS, local authorities, social care and other public agencies, professional working with people at risk, and individuals, local communities and voluntary groups. The next part to this lesson is about UV levels. The main factors affecting the strength of UV radiation reaching the Earth's surface are the elevation angle of the sun in the sky, the amount of cloud, dust and pollution in the atmosphere, and the amount of ozone gas in the stratosphere. The presence of ozone in the stratosphere is important because it absorbs much of the UV radiation before it reaches ground level. Our UV model currently accounts for sun angle and forecast cloud amounts. We use as a climatological value. the average concentration for this time of the year in the UK to estimate the total ozone concentration. During the dark polar winter, the concentration of ozone in the upper atmosphere over the pole typically decreases because sunlight is a critical ingredient in making ozone in the first place. At the same time, the circulation of air in the North Pole keeps all this low ozone air at high latitudes near the pole. In March and April, as the sun moves north, this polar circulation begins to break down and occasionally allows pockets of low ozone air to break away. These can sometimes pass over the UK. In these situations, there will be less ozone in the high atmosphere available to absorb the UV compared to the average amount used in our forecasts. This means that the UV index could be higher than currently indicated in our forecasts, particularly if forecast cloud amounts are low. We do round up our UV values, but due to this low ozone event, the UV forecast can still be lower than the actual levels. Enjoy the sun safely. It is important that if you are in an area that is particularly sunny over the next few days, you take steps to ensure that you and your family are protected from these increased UV levels. You can also get UV forecasts for UK and worldwide locations on the Met Office website or app for the next 7 days. For iPhone, the app is available from the App Store, and for Android, the app is available from the Google Play Store. Our final part of this lesson is about dew. Dew is the small droplets of water that appears on objects such as leaves or grass in the morning or evening due to processes of condensation. How does it form? Dew forms when the temperature of a surface cools down to a temperature that is cooler than the dew point of the air next to it. When this happens, water vapor will condense into droplets depending on the temperature. The temperature at which droplets form is called the dew point. When the surface temperature drops, eventually reaching the dew point, atmospheric water vapor condenses to form small droplets on the surface. Up to 0.5 millimeters of dew can form at night in some climates. Whilst small, this amount is significant enough for dew to become an important source of moisture and for some plants and animals in arid areas. Dew can be collected for human use from canopies erected above the surface, which, with the correct conditions, can collect several litres of water. Dew forms most easily on surfaces that do not conduct heat from the ground. Grass and the rooted tops of cars are some of the most frequently seen examples. It usually forms during the calm weather associated with high-pressure systems. Dew point. The temperature at which condensation occurs is called the dew point and is dependent upon the humidity and pressure of the air. Calculating the exact value of the dew point is important when predicting frost or fog. Dew point may be measured indirectly from wet bulb and dry bulb temperature readings with the air of a humidity slide rule or humidity tables, or directly with a dew point hygrometer. Dew bow. Whilst a relatively rare occurrence, the presence of a dew can cause a similar optical effect to a rainbow. I thought I'd add one more part to this. What is the difference between mist, fog, and haze? Fog and mist differ by how far you can see through them. Fog is when you can see less than 1,000 meters away, and if you can see further than 1,000 meters, we call it mist. We'll first look at fog. In our meteorological glossary, fog is defined as obscurity in the surface layers of the atmosphere, which is caused by a suspension of water droplets. By international agreement, particularly for aviation purposes, fog is the name given to the resulting visibility less than 1 kilometre. However, in forecasts for the public, this generally refers to visibility less than 180 metres. Next, mist. Mist is defined where there is such obscurity and the associated visibility is equal to or exceeds 1,000 metres. Like fog, mist is still the result of suspension of water droplets, but simply at a lower density. Mist typically is quicker to dissipate and can rapidly disappear with even slight winds. It's also what you see and what you can see your breath on a cold day. And finally, haze. Haze, a third term you might also hear mentioned, is haze. This is a slightly different phenomenon, which is a suspension of extremely small dry particles in the air, not water droplets. These particles are invisible to the naked eye, but sufficient to give the air an opalescent appearance. These particles can also contribute to creating a red sky at sunrise or sunset. That's all for today. See you soon. Bye.